Some architectural ideas don't spread because they are officially approved. They spread because they challenge what people think is possible. A steel arc-shaped home design has recently entered online discussions, being described as a structure capable of surviving Category 5 hurricane conditions. These storms are among the most destructive natural forces on Earth, with wind speeds capable of causing complete structural failure in conventional residential buildings, widespread infrastructure collapse, and severe environmental damage across entire regions. Yet this design is being presented in certain discussions as something fundamentally different, a structure that could potentially withstand conditions that normally destroy standard housing systems. And that immediately raises a serious question. If a home is claimed to survive Category 5 hurricane conditions, should it be required to pass government-certified engineering stress testing before being publicly promoted? Or is conceptual design discussion enough? Write your answer in the comments below. Because this question is not just about architecture, it is about safety regulation, public trust, and how far experimental design should go before it enters real-world housing systems. Now, when we step back from the viral framing and look at structural engineering principles, hurricane-resistant construction is not defined by a single shape or material. Instead, it is the result of multiple engineering systems working together under strict safety codes. These include wind load distribution systems, reinforced framing structures, deep foundation anchoring, impact-resistant materials, and aerodynamic shaping designed to reduce pressure buildup during extreme wind events. In regulated construction environments, especially in hurricane-prone regions, buildings must comply with strict building codes that are based on decades of meteorological data, structural failure analysis, and real-world disaster performance studies. These codes are not optional suggestions. They are legal requirements designed to prevent catastrophic loss of life and property during extreme weather events. So whenever a new structural concept claims extreme resilience, it must be evaluated not only as a design idea, but as a system that must pass verified engineering standards before it can be considered safe for residential use. And this is where the conversation around the steel arc concept becomes more complicated. Because while curved architectural forms are not new in engineering, and while they do offer certain advantages in load distribution, the leap from strong shape concept to Category 5 survivability claim is a significant one. And that gap is exactly where most of the confusion begins. When engineers talk about hurricane resistance, they are not talking about one single feature like shape, material, or thickness. Instead, they are talking about a complete system of protection where every part of a structure has to work together under extreme and unpredictable forces. In official building codes used in hurricane-prone regions, especially coastal areas, survivability is defined through measurable standards, not descriptive claims. These standards are based on decades of meteorological data, structural failure reports, and post-disaster reconstruction analysis. A Category 5 hurricane, for example, is not just strong wind in a straight line. It is a complex system of destructive forces. Wind speeds can exceed the limits of standard residential design assumptions, but beyond that, the real danger often comes from pressure changes, debris impact, and sudden shifts in wind direction that create stress patterns across a building that are extremely difficult to predict in real time. This is why modern hurricane-resistant construction focuses heavily on redundancy and reinforcement rather than relying on a single structural concept. For instance, roof anchoring systems are designed to prevent uplift, which is one of the most common causes of structural failure during severe storms. If a roof detaches, the internal pressure of the building changes instantly, often leading to complete collapse of the remaining structure. Similarly, foundation systems in hurricane zones are engineered to resist both lateral and vertical movement. This often involves deep anchoring into the ground using reinforced concrete systems or specialized pile foundations that distribute load across stable soil layers. Wall systems are also not just about strength, they are about impact resistance. In real storm conditions, flying debris can strike buildings at high speeds, meaning materials must be tested not just for wind pressure, but for direct impact resistance under simulated conditions. Now, when a concept like a steel arc home is introduced into this context, the immediate engineering question is not whether the shape looks strong. The question is whether the entire system, including materials, connections, anchoring, and load distribution, has been tested under certified hurricane simulation conditions. Because in structural engineering, a shape alone does not determine survivability. A dome, an arc, or a curved frame can distribute forces more efficiently in theory, But if the joints, materials, or foundation fail under stress, the entire advantage of the shape becomes irrelevant. This is why engineers rely heavily on wind tunnel testing and computational structural analysis before making any performance claims about a design. In these tests, structures are subjected to controlled simulations of extreme weather conditions, including varying wind speeds, directional changes, and debris impact scenarios. The goal is not to see whether a structure looks stable, but whether it maintains integrity under repeated stress conditions that replicate real-world disasters. And even then, certification is not based on a single successful test. It requires consistent performance across multiple simulations and compliance with strict regulatory frameworks. This brings us to an important distinction that often gets lost in online discussions. There is a difference between an architectural concept that demonstrates potential resilience and a fully certified residential structure approved for construction in regulated environments. One exists in theoretical or experimental space. The other exists in legal and safety-verified reality, and this distinction is critical when evaluating claims about extreme weather survivability. Because without verified testing and certification, any statement about withstanding Category 5 hurricanes remains an engineering hypothesis rather than an approved safety guarantee. At this stage of the investigation, one thing becomes clear. The conversation is not just about whether a steel arch design can handle wind forces. It is about whether the entire structure meets the strict multi-layer safety requirements that govern real-world residential construction in extreme environments. And that is where the next part of the discussion becomes even more important. Because once we understand how real hurricane-resistant homes are built, we can start comparing them to viral design claims and see where reality and speculation begin to diverge. In construction and engineering law, words matter far more than most people realize. Because terms like hurricane-resistant, storm-rated, or especially hurricane-proof are not casual marketing phrases in regulated environments. They can fall under strict legal scrutiny depending on how they are used, where they are used, and whether they imply guaranteed performance. In many jurisdictions, including hurricane-prone regions, building claims are tied directly to liability standards. This means if a structure is advertised in a way that suggests absolute survivability under extreme conditions, regulators and insurance authorities may require documented proof that the structure has been tested and certified under recognized engineering codes. This is because in real-world disaster scenarios, false or exaggerated safety claims can have serious consequences. If a homeowner believes a structure is fully immune to Category 5 hurricane damage without certified backing, that assumption can influence life safety decisions, evacuation behavior, and insurance coverage expectations. That is why official building codes do not use absolute language. Instead, they define performance thresholds. For example, structures are designed to withstand specific wind speeds, pressure loads, and impact conditions within calculated safety margins, rather than claiming total immunity from natural disasters. Now, when online discussions begin describing a design as unstoppable or fully resistant to Category 5 hurricanes, that language immediately moves away from engineering terminology and into promotional interpretation. And that shift is where regulatory sensitivity begins. Because in construction law, any implication of guaranteed structural survival without certification can be considered misleading if it is presented as a factual performance standard rather than a conceptual idea. This is also where insurance frameworks become relevant. Insurance providers rely heavily on certified risk models when determining coverage for properties in high-risk zones. If a structure is not officially recognized within those models, its claims cannot automatically be translated into reduced risk classification or guaranteed survivability status. So even if a design appears strong or innovative, it still must pass through formal evaluation channels before any performance claims can be legally recognized. This is why many experimental architectural concepts remain in the research or prototype phase for long periods before they are ever considered for residential deployment. Because engineering innovation does not exist in isolation. It operates within a framework of legal accountability, public safety regulation, and financial risk assessment. One of the most common patterns in viral architectural or engineering claims is the blending of real scientific principles with exaggerated performance interpretations. In the case of curved or steel arch structures, the underlying engineering concept is not fictional. Curved geometries can indeed distribute stress more efficiently under certain conditions. This is well established in structural mechanics and has been applied in bridges, domes, and long-span architectural systems for centuries. However, the transition from efficient load distribution to Category 5 hurricane survival guarantee is not supported by standard engineering validation without extensive testing. This is where marketing interpretation often diverges from engineering documentation. In many cases, simplified explanations remove critical variables, such as material fatigue limits, connection strength, foundation anchoring depth, and dynamic load variability. These factors are essential in determining real-world performance, but are often excluded from simplified presentations for broader audience appeal. As a result, the public perception of a design can become significantly more optimistic than what formal engineering analysis would support. This does not necessarily mean that the underlying concept is invalid. It means that the representation of its capabilities may not fully reflect the complexity of real-world structural performance evaluation. In professional engineering practice, any claim of extreme environmental resistance must be backed by simulation data, physical stress testing, and compliance verification with recognized standards such as wind load codes and structural safety regulations. Without these elements, a design remains conceptual rather than certified, and this distinction is critical when evaluating any architectural innovation presented to the public, especially when it involves extreme weather survivability claims. At this point in the investigation, we need to separate two very different things that often get blended together in viral discussions: experimental architectural concepts and fully verified real-world residential construction systems. Because when we look at actual engineering practice, hurricane-resistant housing is not a mystery field anymore. It is a highly developed discipline with decades of research, strict building codes, and continuous updates based on real disaster data. In real-world applications, there are already structures designed to withstand extremely high wind loads. These are typically built using reinforced concrete systems, steel framing with engineered connections, deep foundation anchoring, and aerodynamic roof designs that reduce wind-uplift pressure. In some coastal regions, homes are also elevated on pilings to reduce flood damage risk, and building envelopes are reinforced to prevent internal pressure failure during storms. However, even these certified systems are not described as unstoppable. Instead, they are classified based on performance thresholds, such as wind resistance ratings and compliance with regional hurricane building codes. Now, when it comes to the specific idea of a steel arch home, it is important to note that curved and dome-like structures do exist in modern engineering. Dome architecture, shell structures, and arched frameworks are widely used in stadiums, industrial buildings, and specialized shelters because of their ability to distribute stress efficiently. But these real-world applications are always backed by engineering validation, structural testing, and compliance with safety regulations before they are used in occupied residential environments. So while the idea of a steel arch structure is not impossible in engineering terms, the claim that it can automatically survive Category 5 hurricane conditions without detailed verification is not something that is accepted in formal construction standards, because in engineering, survivability is not declared. It is proven, and proof requires data, testing, and certification, not just conceptual design or visual representation. Interestingly, the future of hurricane-resistant housing is not focused on a single, perfect shape or miracle structure. Instead, ongoing research is focused on adaptive resilient systems. These include materials that can absorb impact energy without structural failure, modular building systems that allow damaged sections to be replaced quickly after storms, and aerodynamic designs that reduce wind pressure buildup across surfaces. There is also increasing interest in smart structural monitoring systems that use sensors to detect stress changes in real time during extreme weather events. This allows for early warning systems within buildings themselves, potentially improving evacuation timing and structural safety responses. In other words, modern engineering is moving toward layered protection systems rather than absolute invulnerability claims. Because in real disaster science, the goal is not to create a structure that never fails under any condition. The goal is to create structures that fail safely, predictably, and within controlled limits to protect human life. This is a critical distinction that often gets lost when viral architectural claims enter public discussion. So when we return to the original claim of a steel arch home that can survive Category 5 hurricanes, the most accurate conclusion based on engineering principles, building code standards, and real-world construction practices is not that the idea is impossible, but that it is incomplete without verification. The underlying structural principles of curved design, stress distribution, and aerodynamic shaping are all real and widely used in engineering. However, survivability under extreme hurricane conditions depends on far more than shape alone. It requires material certification, structural testing, foundation engineering, impact resistance validation, and compliance with strict regulatory frameworks. Without these elements, any claim of unstoppable performance remains theoretical rather than certified, and this is why such concepts often generate controversy. Not because innovation is discouraged, but because in engineering, safety is not based on possibility, it is based on proof. So now I want to leave you with one final question. Do you think future home designs should prioritize experimental innovation even without full certification, or should strict engineering validation always come before public adoption? Let me know your thoughts in the comments below. And if you found this investigative breakdown valuable, make sure to subscribe to the channel, press the bell icon so you don't miss the next deep dive documentary. Also drop a comment and tell me what topic you want next, whether it's hidden building technologies, energy myths, or real-world science behind viral engineering claims. See you in the next investigation.